Ever wonder how engineers actually know if an AI is getting smarter or if it's just getting better at faking it? We're going to show you how we measure the soul of a language model, from its logic to its safety, and why most of the numbers you see online might actually be lying to you. Our story begins with the problem of the fuzzy mirror. Because AI can output anything from poetry to Python code, traditional grading doesn't work. If you ask a human to rate an AI's advice on a birthday gift, one person might call it sweet, while another calls it useless because it didn't specify exactly which brand of teddy bear to buy. To fix this, researchers use inter-rater agreement metrics to ensure humans aren't just guessing, but human grading is slow, expensive, and it doesn't scale. This led to the era of rule-based robots and metrics like Meteor and Blue. These systems compare AI answers to a perfect human reference. But there's a catch. They are rigid. If the AI says a plush toy instead of a stuffed animal, the robot gives it a 0, even though the meaning is identical. The real breakthrough came when researchers realized they could use the AI to police itself. This is LLM as a judge. By asking a more powerful model to explain its reasoning, a rationale, before giving a score, we get a grade we can actually trust. But even these digital judges have human flaws. They suffer from position bias, preferring whichever answer they read first, verbosity bias, favoring longer, wordier answers, and self-enhancement bias, where an AI secretly prefers its own writing style over competitors. To truly test an AI's mettle, we put it through the academic gauntlet, a series of benchmarks that act like the SATs for machines. MMLU tests its broad world knowledge across 60 subjects like law and medicine. Amy and PyQL push its logic, asking it to solve complex math or explain common-sense physical problems, like why you'd use a hairnet to find a lost earring in a carpet. Then there's SWE Bench, which forces the AI to act like a software engineer, fixing real bugs on GitHub to prove it can actually build things, not just talk about them. But as we reach the frontier of AI agents, models that can browse the web or buy tickets for you, evaluation becomes a simulated life. Using frameworks like TauBench, we simulate a user and an agent in a loop to see if the AI can actually complete a task, like changing a flight, without breaking the database. The ultimate lesson? A high score on a test doesn't always mean a good model. When a measure becomes a target, it ceases to be a good measure. The only way to truly know if an AI is ready for the real world is to test its reasoning, its safety, and its ability to act.